on the computer, they would come to me saying, how do I get the eigenvalues of a 4x4 matrix? And I would tell them there's a library routine called this, go read about it and use it. And they would be back 20 minutes later saying, what does it mean about these error conditions? And then they'd be back 30 minutes later with something else. And I became the person, it was always easier for me to do it. And so I would end up programming it. And actually, after a while, sort of in self-defense, I started writing this interpreter. Now, some of you look old enough to remember this period. This period, everybody was writing in assembler language because everybody was concerned about machine cycles. That was the big thing that cost money. And I wrote an interpreter using Fortran, which was a language that was essentially discredited because it didn't do as well as assembler. And when anybody who really knew computing learned about Speakeasy, which was this language I wrote, they would sort of laugh because it was designed sort of as a way for a physicist to use a computer. Now, the physicists in the group didn't laugh because they would punch up their cards and put it in the machine and their answers would come back. And that's because the language was sort of designed for them. They didn't have to learn to program. And that resulted actually in a very interesting phenomenon. They would complain. They'd come to me and say, why do I have to put a comma after a number? And I would duly explain to them that it was needed so I could scan it and see it. And then I'd go back and say, is it really necessary? You know, anytime somebody would complain, I'd look at it and say, is there some way I could fix it so it didn't do that? And so our users actually designed the language in a funny way. They said, do you have this operation? Do you have that? And I would put it in. And eventually it grew up to be a language which essentially they had designed. It had words they knew and sort of a nice language. They thought it was marvelous. It had a very small audience inside Argonne, which was nice because there was no pressure from outside to get it fixed. And so I could do it at my leisure. And there were one or two people who would periodically join the group to help write Speakeasy operations. So it grew rather slowly with a very active user group in a small group. Then in the early 70s, I started going to share meetings, which is the IBM user group. And the first meeting, I picked up a few people who were interested. We were giving it away, and they sort of thought it was cute, and they would put it on their machines. It was one of the first programs that ran on TSO when it was introduced. It was sort of an interactive problem-solving tool under TSO. And sometime in the early 70s, and I can't quite date any of these, this graph has numbers, but there are uncertainties in them. Somebody from the Federal Reserve Board, namely Jim Condi, who's sitting on this side, discovered Speakeasy in a demonstration of ARPANET. It was running at UCLA, and somebody apparently came to Jim and said it does matrix algebra. And it does matrix algebra because theoretical physicists, at least my group, uses matrix algebra, so it had built-in rather natural notation. And I was somewhat surprised to discover that the Federal Reserve Board was interested in this thing. And my first encounter, they said they essentially think in matrix algebra, so we ended up with a rather wild group of people using it. From my perspective, they'd say, do you do this? And I'd say, what does that word mean? And I've learned some of the vocabulary now, but not much. But then they discovered the other feature, which is the language. Since we didn't have a development team, it was only a few people, we designed it so anybody could extend it. And anybody can write what are called linkules in the language, and these are the words that are the vocabulary of Speakeasy. So the first thing that happened with the Fed was they discovered it had matrix algebra, but then they started complaining that it did not have a really good statistical package. So they added it, and they gave it to us. And eventually it started growing, and we had Speakeasy users who wanted the matrix algebra, wanted the statistics. The Fed also discovered they could talk to their database through the extensions, and so they had a system which became, I think, the dominant language for the econometricians at the Fed. And they kept adding these words for us, which we didn't know anything about. There were words called things like simulation and forecasting, and I don't know what they do exactly. I know the words as English. Sometime in the early 60s, we also had the University of Waterloo sort of saw Speakeasy, they liked it, and they produced a CMS version for us. And it was parallel to the version that we had running, a TSO version. And that